Assalamualaikum and hi. My name is Nini Adriana and I'm together with my lab group members who like to present our lab report to which on creep test. Before I next, Before I start, let me introduce briefly my lab group members. So here we have Afi Azmasa, Alif Haris and Amira Izzati. Now let's get started. Next. So what is creep? By definition, creep is an undesirable deformation that occurs when the material is placed at a rising temperature surface while being exposed to static mechanical stresses. Therefore, as highlighted in the slide shown, temperature and static mechanical stress or load are the important parameters that can contribute to creep and accelerate or decelerate the process. Besides, it is a plastic or permanent deformation with time-dependent asymmetry subjected to constant load or stress. It is also known as a high-temperature progressive deformation under constant stress. With that being said, creep is clearly closely related to the sustainability of a particular product's materials, such as turbine rotors, steam generators, and so on. Next. So to know that, we need to run a creep test. Creep test is conducted by subjecting the specimen to constant load or stress when the surrounding temperature is kept constant until it fails. Specifically, it is being performed to measure how a selected specimen will perform under constant load and elevated temperature after various time intervals. Then, the graph is distinguished within three regions, which are the primary region, the secondary region, or known as steady-state creep, and lastly, the tertiary region. Next. In Lab 2, our experiment's objective is to compare and analyze the mechanical properties of the polymer and metal by conducting creep tests. So the polymer we choose is high-density polyethylene HDPE, while the metal is lead. Next. In daily life, lead is used as pipe since Roman ages due to its strength and so on, while HDPE is almost everything around us like plastic, cable insulation, and many more. I pass to Amira Izzati.
Next, I'm going to present about the methodology of creep test. Next. For the apparatus and material, we are using creep machine SM1006, weight versatile data acquisition system, or as known as VDAS, lead creep test specimen, and lastly, high density polyethylene creep test specimen. Next. For the procedures of this experiment, we start off with the lead creep test specimen. Firstly, we measure and record the width and thickness of the lead specimen. Then, we prepare the creep machine by putting the weight hanger in position and fit its support pin in its highest hole to hold the arm up and ready for the lead test specimen. And then, we fit the lead specimen into the place between the support block and the arm and fix the pin. And the next step is record the temperature around the lead specimen. Next. After that, we fit a suitable weight to the weight hanger and enter the measures into the VDS. And this step is to give a stress that gives the longest test time that are allowed. Next step, we prepare the time data acquisition for 30-second intervals and continue indefinitely. After that, we carefully remove the weight hanger support pin from the highest hole in the weight hanger and start the experiment by switch on the digital indicator and press its button to set it to display to 0. And please make sure that it is set to work in reverse. Next. Then we can lift the weight hanger and support it while fit the support pin in its lowest rubber mat onto the base plate underneath the weight hanger and record the lead specimen extension every 30 seconds until it fractures or stops extending due to the limits of the machine. Then we repeat the creep test using high-density polyethylene specimen, and lastly, we analyze the recorded data and plot graph extension versus time for both specimens. I'll pass to Alif.
I would like to explain the lead behavior during the creep test. Next. First off, the data obtained from this creep behavior is a representation, the general figure of creep graph, showing that this graph obtained is very accurate. Next, I would like to explain the three behavior of primary region in this graph. First off, we have the primary creep. at this point, the creep rate for lead is decreasing, which cause the lead hard for this formation to occur. This is because the lead material increase in creep resistance or also increase the in strain hardening. Next, we have secondary creep. So in this region, we obtain a linear graph representation showing that the balance between the strain hardening and recovery of lead specimen. Next, we have tertiary creep. In this region, it almost reach failure where the creep rate accelerate. This is because the grain boundary of lead separate and formation of internal cracks, cavity, and voids. At this point, lead probably experience necking. Next.
Next, we move to the discussion of polymers, which is high-density polyethylene. Here we have two set data table creep using 87 Newton and 93 Newton. Okay, moving on to the classification on type of polymers. The specific type of polymers is not mentioned at first when these data are obtained. However, the dimensions of specimen used in this experiment are given. In order to determine the specific classification of polymers, first we have to find the stress by taking any arbitrary force divided by the sectional area of specimen. Then, modulus of elasticity is computed using Hooke's law, and eventually, the answer is used to find the correlated type of polymer, which is HDPE as shown in the table, that has smallest difference compared to other types of polymer. After that, the strain versus time graph is plotted based on the data obtained in both tables as shown before. As can be seen in this graph, it clearly shows that the higher constant load or stress exerted on the specimen, the shorter the duration for the specimen to rupture in the creep test, as the constant load of 93 Newton only takes 0.44 minutes, while the constant load 87 Newton takes for about 1.32 minutes to rupture. However, in this regard, only 87 Newton load line will be discussed as it provides the clearer picture for three stages of strain time behavior, which are primary, secondary, and tertiary creep. The specimen undergoes first stage of primary creep for the first 0.2 minutes approximately from the graph, where viscoelastic strain is linearly with the decreasing creep rate. In this stage, the specimen is experiencing strain hardening. Then it moves to the second stage of steady state creep up to 1.167 minutes, where the specimen is balancing between the recovery of its deformation and strain hardening, shown by the constant creep rate during the secondary stage. The plastic subsequently moved to the final stage where the creep rate is increasing along with time and rupture eventually. In the molecular level perspective, the constant applied load or stress has overcome the hydrogen bonding and weak intermolecular force of attraction between the polymers chains, resulting to chains to liberate. Thus, the rupture lifetime for HDPE is 1.32 minutes. Random error is identified in this graph for 97 Newton that shows fluctuation happen during the secondary interval, presumably due to the measurement judgment and unpredictable vibration of machine. Therefore, assumption has been made where fluctuation region is assumed to be linear by drawing a trend line in the Excel for this region. And next.
Okay, in conclusion, based on the result obtained, it is shown that the lead has a higher toughness and longer rupture lifetime than HDPE despite the occurrence of random error, since the best fit line has been drawn separately in the other graph. Overall, the objective of the experiment is achieved. That's all from us. Thank you.